Hey everyone, welcome to my channel. Today we are diving into something very exciting, integrating Langfuse with large language models for a smarter, traceable AI workflow. If you are new to LLMs or Langfuse, don't worry. I'll walk you through everything step by step. By the end of the video, you will see how to run Retrieval-Augmented Generation setup with Ollama LLM, track every prompt and response using Langfuse, and even log root code to make decisions on your prompt variant. Let's jump in. Before we get into the code, let me give you a quick overview. We are going to do main three things: load some text document into FAISS vector store, set up LLM and embedding using Ollama, using Langfuse to trace our prompts, responses, and scores. Langfuse is amazing because it lets you track your experiments in detail. You can see which prompt worked best, compare responses, and even attach scores to guide your decisions. For someone just starting out, this is super helpful.
First thing first, you should have Ollama and Docker Desktop in your system. Let's pull all the required LLM and embedding models within Ollama. I already have pulled all the models, so it was quick. Then head over to Langfuse GitHub page and run these commands to run the Langfuse container in your local. You need to install Docker or Docker Desktop in your local to run this container. Once the container is up, go to the Langfuse console, which is open at port 3000 in your machine. And post that, create a new organization. And once the organization is created, you can create a new project under it. You can name anything that you want. Okay, once the organization and project are created, go to the setting and create new API keys. Note down the secret key and public key. After you clone the repo, these files will be downloaded. Link of the GitHub will be added in the description. After cloning, you need to create this env file. Inside the env file, you need to add this information pertaining to Langfuse. The secret and public key you need to fetch from your own Langfuse container that I showed earlier. Post that, please create a virtual environment and activate it. Post activation, install the dependencies from this requirement.txt file.
First, we import all the necessary packages, things like text loader and FAISS for handling documents, Ollama LLM and Ollama embeddings for our local language model, and of course, Langfuse for observability. We also import the root scorer because later we'll calculate root L score to compare our answers to a reference text. Here is where Langfuse comes in. We create a client using getClient and call a callback handler with the Langfuse callback handler. This is super important because every query we send to our LLM will be traced automatically. You can log inputs, outputs, and even add custom scores. Think of it as a smart dashboard for your AI experiment. Next, we set up Ollama LLM with Mistral model and a low temperature to make the output deterministic. We also set up embedding using BGEM3. These embeddings are what allows FAISS to perform semantic search across our document chunks. We load the text file called sample.txt, split it into chunks using recursive characters text splitter, and then store these chunks into FAISS. FAISS will act like our brain memory. It lets us quickly retrieve the most relevant pieces of context for any question we ask. Now we define a simple prompt template. telling our LLM to answer a question using context. Then we create retrieval QA chain. Notice how we pass in our retriever and the prompt. This setup allows the model to fetch relevant chunks from FAISS before answering. Here is where Langfuse shines. We start a span called RAG experiment. Everything inside this span, our input question, the output of variant A and B, is automatically logged. We run two variants. Variant A is a straightforward answer, who is Albert Einstein. Variant B, the same question but asking the model to explain in detail. Langfuse tracks both output in real time. We also calculate Rouge L score for both the outputs to see which variant matches our reference text better. Then, using a decision span in Langfuse, we pick the better variant. Everything, inputs, outputs, scores, and the final choice is neatly tracked in Langfuse. Later, we can visualize all this in their dashboard to understand model performance and improve prompts. Finally, we print the answers, log the loose scores, and make a decision for the better variant. At the end, we flush everything to Langfuse. This workflow is super powerful because it combines retrieval, generation, evaluation, and observability all in one seamless pipeline. And with Langfuse, you can trace and optimize every step.
So let's demonstrate. Let us run this Python file. It took some time. Now the results are out. You can see it has selected variant A as per the root score calculation. Now head over to Langfuse console. For each run, it will generate a trace with all the metadata like timestamp, span name, in this case, RAG experiment, the question we asked in the form of a prompt, the response we received, latency of response, root score calculated, etc. If you go inside, you can see all the information more in detail. You can also observe a dynamically created graph depicting data lineage and provenance.
That's it for today's walkthrough. If you enjoyed this deep dive into Langfuse and RAG workflows, hit the like button, subscribe for more AI tutorials, and leave a comment if you want me to do a full dashboard demo for Langfuse next. Trust me, once you start tracing your LLM with Langfuse, debugging and improving your models become very easy. Thanks for watching. I'll see you in the next one.